It's okay. That down. Working here. Here it is. Got it. Done. Down low. Okay. I got everybody there. Now the moment of truth. Let me share my screen. All right. Start the broadcast. I'll go ahead and suppress. Let's optimize. Suppress that. Okay, so give me just a split second longer. Where is this thing? All right. Oh, here it is. Nearby. Okay. Yeah, I was gonna say, let me see. See, I'm not getting my confirmation. Like it gets Yeah, I don't understand why it freezes where it does. Let me go here. Okay, let me just do this. So I didn't get a chance to do what I did last time because whatever I did last time seemed like it worked. I just didn't get the opportunity today to do it. Let's see. I should see a flower. So I didn't get a chance to do what I did last time. Whatever I did last time seemed like it worked. I just didn't get the opportunity today to do it. I should see a flower. No. Ugh. Because it's kind of hard for me to do it if the image is not being pushed. So I didn't get a chance to suppress that. Let's see. Okay. Okay, give me a moment, guys. I'll be right back. All right, so let's give this a go again. Let me try this again. Start the broadcast, and let's see if I can get my verification. I should be able to see the flower. While I'm waiting on that verification, let me go ahead and get these other things back up and running. Allow. Stop.
Morehouse?
Come on. Allow. Let's see. Yeah, it's still freezing on the same page. Okay. Let me close this. Delete that. Let's close this. Let's close this. Let's close this as well. I'll get them in just a moment. Because right now I'm just trying to get my image to push. And again, I never really do anything different. I just kind of keep trying and then eventually it gets through. Start the broadcast. Okay, let me open this back up. This one. Verify. Still no image. Yeah, guys. I don't really know why the images are being pushed. Stop. Share. Screen. Okay. Still nothing. Yeah, I don't know, guys. Stop. Okay. All right, I should be able to see my desktop. Let's see. All right, I should be able to see my desktop. Still nothing. All right, so Yeah, I don't really know. I've restarted my device. I've done things, so I don't, you know, I'm just going to kind of keep trying. So I'm going to have this because of stuff like this. Like again, I don't really know why it's not working because there's no reason for it not to work. Um, but this is why I pre-recorded my lectures. This is why I piggyback off of that. This is why I make my stuff in advance. So when the devices decide to act like this, then we have to use pre-recorded lectures. But I do want to try to get through as many homework assignments as possible, and I want to kind of do it for our allotted time. So I think I'm going to keep trying to log in or keep trying to get my image to push, and then I'll just kind of commit to like working on problem sets for like an hour and 15 minutes. And it's whatever your schedule is that you need to do, that's fine. But at least there'll be a recording. There'll be a stream with that allotted amount of time, and this is what we can do until we can get this image to work. Now I could maybe not choose that. Okay, let's try this. If I turn that off, I think that might make a difference. If I go like this, let's see. All right, that shouldn't make a difference, but I should be able to see my desktop. Okay, I can see it there. It's showing signs of life. Let's give it a few more seconds. It looks good. That's good enough for me for right now. Okay. So again, if you guys, we're going to go ahead and move forward with everything. We're scheduled to run from 6 to 7:15. We got started about like 30 minutes late. So I'm not going to keep you past 7:15, but I'm going to, for myself, probably try to go until maybe 7:45 or closer to 8. Just to kind of honor the time, let me go ahead and give attendance credit for these gentlemen, because I don't want to like take time away from you guys. I want to at least make myself available for our agreed upon time. So there's this student, and there's the other one. Okay. All right. So again, my goal is to go till about 7:45. Once 7:15 rolls around, or whenever, if you need to kind of like step out, it's totally okay. But I at least want to give you the hour and 15 minutes of like content that's live. So it's just been offset by like 30 minutes. Let me log back in. And so again, so our exam one should be available. I know I got some emails. I don't know. I think some of you guys asked questions. If you need, I guess I could pull it up. Let me pull it up, because I think some of you guys did ask questions. If I can get this thing. It's like totally throwing a tantrum today for whatever reason. Sign in. Allow. Right here. Okay. Let me pull it up here. So if I check really quickly, Morehouse, let me see. Reply to that. Okay. I see a couple there. I think it's just those two. Let me see. 1.4. Okay, yeah, let's pull this up. Let's see if I go like this. And what I'd like to do, which of these lines? Okay, let me share. Okay, let's see if this works. Cool. All right. Okay, that was an interesting. What I did was open up the question on my phone. Once I pulled up this page, then I just shared this page with my iPad. Anyway, so we'll let this be. Let me see. Let me think if there are any announcements before we kind of get into this. So again, we're working on exam one. It should be covering chapters 1 and 2. You get unlimited attempts. You're welcome to take this content, this material, and sit down with the tutors or your classmates. And you can work on it with them. Like, it's totally okay. You can ask me questions if you're working on your exam. Even if you finish it, if you feel like you can recover some points, or even if you want help before you submit it, I don't know if you can save exit and come back to it, but just ask questions and just try to get it submitted. Okay. So again, on Monday, what we did, we went through as much of we ended up working on chapter 2 because the students had asked questions and all the questions just happened to come from chapter 2. So we just went on and let Monday be devoted to chapter 2. So today we're going to focus. The goal is to focus on chapter 1, but it really depends on wherever you guys ask questions. So this first question comes from section 1.4, question 43. It says, which of the following lines in the following graph appear to be tangent lines? Why or why not, right? So tangent lines are lines that's going to graze the graph at a point. It's going to cross our graph at one point, but not cross like at a 90, but it's going to like graze, right? So examples of lines that are tangent, let me see, let's zoom out some more. Oh, is this already? Okay, so it says B and F, L5. Which of the following graphs appeared? No, L5 is not tangent, right? That crosses. L5 is an example of something that crosses. L4 is a tangent because it grazes the curve, right? So let me see. Can we edit these? Okay. So here, I think we can work this. Okay. So examples of tangent lines would be like L2, right? L2 should be a tangent. L3 looks like a tangent. L4 looks like a tangent. Not L5. L6 looks like a tangent. All right, those are the ones that look like tangents. So it looks like everything except L1 and L5. Okay, we're gonna check this. All right. Okay. All right. So then, why do the lines selected above appear to be tangent lines, and why are the other lines or lines not tangent lines? All right. So A says the slope of each selected tangent line appears to be undefined. No, it's not A. That's not it. It says the slope of each tangent line is equal to the slope of the graph at the point of intersection between. No, that doesn't sound right either. Let's look at C. It says the slope of each tangent line is approximately 0. That's not it. No. Let's look at D. Each tangent line is perpendicular to the graph at the point of intersection between the graph and the respective tangent line. The other lines are not perpendicular to the graph. No, let's go back to B. The slope of each tangent line is equal to the slope of the graph at the point of intersection between the graph and the respective tangent line. The other lines are not parallel to the graph at the point of tangency. Let's see. The slope of each selected tangent line appears to be undefined. No. The other lines are parallel to the graph to be tangent lines, right? Okay. Okay, let's try. Let's see. The slope of each tangent line is equal to the slope of the graph. Okay, at the point of intersection between the graph and the respective tangent line, the other lines are not parallel. Okay, I think it is B. Because let me see. The slope of each is not A because the slope of each selected tangent line appears to be undefined. No, the slopes are defined, right? For tangent lines, the slopes are defined, so it's not A. The slope of each tangent line is approximately 0. No, right? You can have a tangent line that has a slope of 0, but that's not what makes a tangent, right? So it's not C. And then each tangent line is perpendicular to the graph at the point. No. Like L5 is a little bit closer to being perpendicular, but that's what the image is going to be like. And that's the wrong concept, right? It's not perpendicular. It's more so parallel. It says the slope of each tangent line is equal to the slope of the graph at the point of intersection between the graph and the respective tangent line. The other lines are not parallel to the graph. Yeah, that one is the closest. That one sounds correct. Okay. Yeah, we had to kind of read through it a few times, but we eventually got there. Oh, was that it for that one? Okay, so then there was another question. I know, let me pull it up right here. So we just did that one. Let's do this one. Okay, here. This also comes from section 1.4. All right, let me share right here. So that's good to know that I can do those. Yeah, all it is. I just got to start setting up sooner. I don't know. It's really temperamental as to why it does or does not work, right? So, anywho, it says in this example, we're asked to list the points in the graph at which the function is not differentiable. So, not differentiable is going to occur if we have a hole or a gap or a sharp corner. Yeah, right. So x5, x5 is good. If we look at b, x1 is not differentiable there, right? Because we have an asymptote there. So it's not differentiable. So then c, x0 is good. We can find the derivative there. D, x2, there's a gap there, right? It's not defined there. So yeah, I'm gonna say it's not differentiable there. Okay. X3 is a sharp corner, so that's not differentiable. And X4, same kind of deal. I'm gonna put that one as well. Okay, let's see what happens. Okay. Okay. I think those are the only two questions I saw that students use to ask my instructor. So what we'll do now, we'll just open up chapter 1 and just kind of jump around the sections with the time that we have. And again, I'll just do a stream that's an hour and 15 minutes long, and I just offset everything by like 30 minutes because that's how far we started like 30 minutes late. Let me check on you guys in Zoom really quickly. Okay, look at these students. This one. This one. Okay. There, that looks good. Let me let these gentlemen in. Okay. Right here. Okay. All right. So let's see. Now, if we're doing chapter 1, okay. Let me set a timer for 10 minutes. Hey, Siri, set a timer for 10 minutes.
10 minutes starting now.
Okay, and I'll just spend about 10 minutes on each section. So let's improve the score. That's fine. Continue. I get the late penalty thing. And I'll try to do questions that we haven't done, right? If we have a check, that means we've worked on it together. So let's look at, or at some point, so let's start with this. Let's just do the ones that don't have checks. Here, we're asked to graph. Actually, that's a review question. I'm going to skip that one. Stop. Okay, this comes from 1.1. It says graph the function and then find the specified limits. When necessary, state that the limit does not exist. So for graphing a piecewise function, what we do, basically you graph it like normal, but then, those lines tell you the restriction on the domain, right? So for instance, if we look at the first line, that's like y equals 2x plus 6, right? So we will graph y equals 2x plus 6 like normal, but then it says this only applies when x is strictly less than -3. So this only applies for the portion of the graph that's to the left of -3, right? And then when we're greater than or equal to -3, the graph is y equals x. It's a 0. Okay. So let me see. When x is -3, the corresponding y is 0. Okay. So I think it's B, right? Because I kind of basically what I did was like choose several values of x, find the corresponding y. So when x is -3, if I'm looking on that first line, there's going to be an open circle, and it's going to get the y value is going to get really close to 0 when we plug -3 into the first one, right? But it needs to be an open circle. And then when x is -3, the corresponding y is also going to be -3, and it's going to be the diagonal with a closed circle. So B is the only one that behaves in that fashion. Okay, I'm going to go with B. If I need to kind of go deeper into that or say something different, just let me know. So then we're asked to find the limit as x approaches -3 from the left, right? So as we approach -3 from the left, that means we're going to use line 1. And then from there, if we plug in -3 into line 1, the limit's going to approach 0, right? So the limit as x approaches -3 from the left is going to be 0. Let me turn this off. Come on. 0, right? Okay. And then the next part asks us to find the limit as x approaches -3 from the right. So as we get closer to -3 from the right, that says that we use line 2. So if we plug in -3 into line 2, we get -3. Okay. So -3. So then the limit itself, right? So now one thing that we said, for the limit to exist, the left-hand limit has to equal the right-hand limit, all right? The left-hand limit was 0. The right-hand limit was -3. Because these two numbers are different, the limit does not exist, right? So that was a good recap question. That was one of the first concepts that we talked about. Let's try another one. Let's try, have we done this one? It doesn't look like we've done this. Let's see. In a particular city, taxi cab charges passengers $2.20 for entering the cab, and then 40 cents for each 1/5 of a mile or fraction thereof travel. If X represents the distance traveled in miles, then C of X is going to be the cost of the taxi fare, which is this. Okay. The graph of C is shown to the right. Use the graph to find each of the following limits, right? So this is the graph of C. So when the client enters the car, right? So the distance traveled, as soon as they get in the car, they charge them $2.20, right? Just to get in. And then 1/5 of a mile is 2/10 of a mile, right? So between 0 and 2/10, they add on, it looks like what, 40 cents? All right, so if it's between 0 and 2/10 of a mile, it's 260. And then every 1/5 of a mile, it looks like it jumps by 40 cents. Okay, this is called a step function, a greatest integer function, right? So it says select the correct choice below if necessary, fill in the box. So the limit as x approaches 0.5, so the distance, 0.52 coming from the left, right? So 0.52 between 0.4 and 0.6. So that distance is going to be charged $3.40. Is that okay? Hopefully that's okay. $3.40. Okay, this is called this is a step function, or it's called the greatest integer function. Let's keep going. Okay, so the limit as x approaches 0.52 from the right. So it's going to be the same thing, all right? $3.40. Okay. Continue. All right, so the limit, so then because the left-hand limit equals the right-hand limit, then for 52 hundredths of a mile, $3.40 is going to be that result, right? So for the limit to exist, the left-hand limit has to equal the right-hand limit, and that's going to give us the value of that limit at that point. Okay. All right, let's keep going. Let's see. We'll go like this. Oh, no. So what's going on here? Okay, we'll let this be the last one from this section. It says the federal tax rate for heads of household is given in the graph shown to the right. Use the graph to find the limit as x approaches 87.67 from the left, 87.67 from the right, and then the actual limit itself. So 87, it looks like 80, no, 87, there it is. Okay, 87.67 from the left, what is that, 10%? So it looks like it's approaching 10% from the left. Okay, 87.67 from the right looks like it's approaching 15%. So as we approach 87.67 from the right, it's approaching 15. And so because the left-hand limit does not equal the right-hand limit, we say the limit does not exist. Okay. All right. It hasn't been 10 minutes, but just in the spirit of, doing new questions. So let's go into the next section because we got a lot. So we want to try to get on as many of them as we can. Homework. Where is it? Let me get rid of this. Let's just go to view. There it is. Hello. Come on. Okay. So let's look at the second section, 1.2, algebraic limits and continuity. Hey Siri, set a timer for 10 minutes.
There's already a 10-minute timer, but I can set another. What should I name the new one?
Just cancel. Hey Siri, stop the timers.
It's canceled.
Hey Siri, set a timer for 10 minutes.
10 minutes starting now.
There we go. That's what I wanted. Okay. It looks like we've gone through many of these. And I think those are more than likely to review. We'll take some time on a couple of these. Because I do want to kind of. So that's an augmented review that doesn't come from 1.2, nor does that one. I think we made it through all of these. So the limit as x approaches 3, right? So if we have the limit as x approaches 3 of 8, that's false, right? This is saying that the y value is always going to be 8. So no matter what x you choose, the output is 8 in this case. So that's why that one is false. Let me see a similar question. All right, same kind of deal. So this would be false. Okay, let's go into the next one. Let's do a similar question. All right, the limit as x approaches 5. Yeah, I think we could just plug in the 5. What is that? Negative 25 plus 10 is negative 15, so negative 20. Negative 20. Okay. Now notice here, if we just plug in negative 6, I think we get 0 over 0. So we need to do some kind of manipulation here. Let's do a similar question. So if we just plug in negative 1, we don't get a result. So we can simplify this. We got x squared minus 1 as difference of squares. So then the top factors into x minus 1 times x plus 1. So then the x plus 1s are going to cancel. And it looks like we're just going to be left with the x minus 1. Now when we plug in the negative 1, all right, we're going to get negative 2. And the reason we can do this, again, we're talking about limits and we're not doing the derivative. So even though when we plug in negative 1, because we get 0 over 0, what that means is that our graph is going to be a hole or a gap, right? It's not going to be an asymptote. It's going to be a hole or a gap. So as we approach that number, as x approaches negative 1 coming from the left and coming from the right, they're both going to approach negative 2, but it's not going to be defined for itself at negative 2. So limits, again, with limits, we're concerned with what happens when we're close. So we could talk about the limit on just slightly to the side of our point in question. Now, if we were talking derivatives, we couldn't do this, right? But for limits, we're okay. Because limits are only concerned with closeness, like when we're close to the number. Let's just do a couple more. Let's do a similar question. It says, determine whether the function shown is continuous. Right. From negative 6 to 6, we see we have that asymptote. So that's going to be a break in our line. Is it continuous? We're going to say no. Just going to go no there. Next question. Use the graph to find the following limits and function values. Okay. Let me do a similar question. All right. So as x approaches 3 from the left, right? So we see we have this gap. So as x approaches 3 from the left, y approaches 3. As x approaches 3 from the left, our y value is approaching 3. Okay. So then as x approaches 3 from the right, our y value is approaching negative 2. So we're going to put negative 2 there. So then because the left-hand limit does not equal the right-hand limit, we say the limit does not exist. Okay. Let me check on you guys in Zoom. You seem like you're okay. Oh no, I definitely highlighted him in because it was two guys together. But I know he's on my attendance. I got his attendance. I don't know why he didn't get in earlier though. Okay. Let me see what else we got. So these are fairly short and sweet, right? So, oh, did we not finish this? Let's finish it. So the function value, when x is 3, the corresponding y, so the filled in circle is at the top. So when x is 3, the corresponding y is 3. So f of 3 is 3. Okay. Let's spend a few more minutes on this section. Okay, let's do a similar question. So it says, use the graph to answer these questions, yada, yada, yada. For A, it says, we're asked to find the limit as x approaches 4 from the right. So coming from the right, it looks like our y values approach 1, 2, 3, 4, 5. So as x approaches 4 from the right, y is getting closer to, it looks like 5. Come on. Okay. And then as x approaches 4 from the left, our y value looks like it's approaching 2. Okay. So then because the left-hand limit does not equal the right-hand limit, we say the limit does not exist. Okay. Let me see. So when x is 4, the corresponding y is 2. It's defined when x is 4, right? The corresponding y is 2 because we have a closed-in circle. Okay. And then, is it continuous at x equals 4? No, right? It's not continuous because not A. It's not B or C because it's not yes. So then D says it's not continuous at 4 because the limit does not exist. Yes, we're going to go with that one. Check the answer. Okay. All right. I think I want to go to the next section. So let me get rid of this. Let's go to view. And let's just go to, hey Siri, stop the timer.
It's canceled.
Yeah, let's look at 1.3, average rate of change. Hey Siri, set a timer for 10 minutes.
10 minutes, starting now.
Okay, yeah, let's try to do the questions that we haven't done. That comes from section 1.3. So if this is a review question, I'm going to skip it. That's a review question. Let's go to the next one. Okay, let's look at this one. Okay, so here we have, we're asked to, it says, find a simplified form of the difference quotient, right? And then complete. Okay, so we need to take some notes, right? So for difference quotient, we see it there is f of x plus h minus f of x. I think I need to not be lazy. I'm tempted to do it in this little space, but I know I should probably write it out. So what I am going to do, I'm going to get a screenshot and take some notes. Just try not to be lazy, all right? Because I totally am trying to be lazy. All right, so we got that. Let's get rid of this, copy and delete. And then what we're gonna do is hop here. That looks good. Let's drop the image. Okay. Now what we could do is kind of like, it's kind of arcane. But I think it's okay. Let's just keep going. Okay. So simplified difference quotient, right? So difference quotient, let's see, that's going to be f of x plus h minus f of x all over h. Okay, so they just want us to do a simplified difference quotient. So first, let's focus on f of x plus h. All right, let's just do that. So then what we're going to do is replace each x with x plus h. So we're going to have a minus 2x squared, right? And we're replacing the x with x plus h. Let me do it like this. X plus h. Right. Okay, so then if we expand that, it's going to be x squared plus 2xh plus h squared, okay? Then ultimately that becomes negative 2x squared minus 4xh minus 2h squared, okay? Okay, so that's the f of x plus h. So now let's take a look at f of x plus h minus f of x. So then we're going to have the result that we just got, which is, is that where that's coming from? That probably is where that's coming from. Sorry. We got this minus 2x squared minus 4xh minus 2h squared. I'm just repeating the above answer. Now I'm going to say minus my f of x. So minus a negative 2x squared becomes double negative is positive. And there's nothing to distribute other than that. We get this, all right? So then we can go ahead and simplify that down. So 2x squared is canceled by this. And we are left with negative 4xh minus 2h squared, right? So we know that we're on track. That's a good omen because the remaining terms all have h, okay? So now for the final part, f of x plus h minus f of x all over h. Now we're dividing that result by h. So I'm going to copy and paste. Copy, paste. And we're going to say divided by h. Right? Notice on top, we can factor out an h from those terms, right? That's what we want, right? If we factor out an h from everything on top, we're left with minus 4x minus 2h, okay? And on bottom, we're still divided by h. Now we get our h's to cancel. So then our simplified difference quotient ends up being negative 4x minus 2h, right? Now, I want you to see this, just to appreciate how far you've come, right? How far we've come together, right? Style like this. So remember, when we introduced the derivative, we said the derivative was the limit as h tends to 0 of this guy, right? If the original, let's do like this so we can see everything. So if the original, come on. There it is. Okay. So if our original is a negative 2x squared, the limit as h tends to 0 of our difference quotient, essentially this term goes to 0 and we're left with negative 4x, right? Now, if we apply our theorem or our shortcuts, when we go to take that derivative, remember the 2 comes down, we get a negative 4x. You see how instead of doing the long difference quotient, we do the shortcut? And think about some of those derivatives that we've done. If we try to do the difference quotient, I mean, we'll be sitting here for a little while to take the derivative. But because of these shortcuts and theorems, we can just jump straight to the result, right? But our simplified difference quotient is going to be this negative 4x minus 2h, okay? Negative 4x minus 2h. So we're going to put here negative 4x minus 2h. Okay, let's go with that. Okay. All right. That's all. When I check those, let me check on you guys' Zoom again now. Okay, you guys are good. So, we are approaching the 7:15, but again, we started maybe like 30 minutes late. So I intend to go until about at least 7:45, right? To at least give you the time that we missed, right? But if you need to leave, obviously you're more than welcome to leave. I'm not gonna make you stay. You're an adult, right? So I'm gonna kind of play like that. But I'm gonna try to cover myself and be like, okay, let me at least make myself available for an additional 30 minutes to offset it. Okay. So fill in the table, right? Okay, so when x is 3 and h is 2, so that's going to be a negative 12 Let me see, negative 12 minus 4, what is that, negative 16? Negative 16. Okay, that's fine. Yeah, it is being temperamental. So then when h is 1, negative 12 minus 2 is negative 14. Okay. 0.1, what is that? Minus 0.2, negative 12. So negative 12.2. Okay. And then the next one is going to be 0.02. So negative 12. So it looks like it's approaching negative 12, right? Negative 12.02. Okay. I think my image is good. It still looks good. Okay. So then we're going to check. All right. I'm going to kind of skip this one for right now because it's similar to what we just did, just a different equation. I might do that one. I'll do one more of these. Let me just kind of do a quick scan. It says the graph shows the number of trips taken annually on a certain state's mass transportation system. Find the average rate of change of the number of trips from 92 to 95. So basically find the slope. 92 to 95, okay. You would just be finding the slope between those ordered pairs. So, you know, you would do 7.4 minus 8.6. What is that? 1.2, a negative 1.2 divided by 3. So negative 0.4. I think it's just negative 0.4 million. Let's do a negative 0.4 and see if that works. Negative 0.4 million per year. Okay. All I did was find the slope between those ordered pairs. 95 and 2000. So for instance, 2000 is 9.7, 95 is 7.4. So that's 1.7. No, if there were 8, yeah, 1.7 plus 0.6. So 2.3. Okay. Hey Siri, stop. Oh, no. No. Hey Siri, stop. Okay. So then I want this to keep going. Okay. I think we got 2.3 for the numerator, and then divided by 5, 2.3. Oh, that's not a clean number. Let me see. Hey Siri, what's 9.7 minus 7.4?
It's 2.3.
And then, hey Siri, what's 2.3 divided by 5?
2.3 divided by 5 is 0.46.
So I'm just going to put 0.46. Okay. All right. Let me see. Let's go into the next section. That was a few minutes there. All right. We're just trying to touch on as many of these concepts together as we can. Okay, let's get rid of this. View. Allow. Okay. So we did average rates of change. Differentiation using limits and difference quotients. Sure. Let's do a few there. Hey Siri, set a timer for 10 minutes.
10 minutes, starting now.
Okay. That's augmented review. I'm going to skip that. Okay, so by determining f prime, I find f prime of 4 for the given function, right? They want us to use the limit now. Just for the sake of time, I'm going to go ahead and just use our shortcut, right? So f prime of 4, so we know how to find this derivative, right? The 2 comes down, it's going to be what, 10x. And then if x is 4, that should be 40, right? So if that's 40, okay. Now, before we go to the next question, 5x squared, let's show the limit definition of that. The limit of the difference quotient definition. We got 5x squared, right? Okay. Okay? 5x squared. So our f of x is 5x squared. Okay, let me kind of, I can. Oh, did you freeze on me? There you go. There you go. So we're given this f of x equal to 5x squared, and we want to see a demonstration of the limit definition of the difference quotient, right? So we introduced the derivative, which is the slope of the tangent line at a point. We introduced it as the limit as h tends to 0 of the difference quotient, which is f of x plus h minus f of x all over h, right? So let's just do this for a moment. Let's first go ahead and find f of x plus h, okay? So then we're going to replace each x with that x plus h, so it's only one of them, okay? If we expand this guy, we're going to have x squared 2xh plus h squared. And if we distribute the 5, this is going to be a 5, this is going to be a 10, and this is going to be a 5, right? So all I did was FOIL and then distribute my 5. Okay, and I got this result. So now that's f of x plus h. Now we want to consider f of x plus h minus f of x. So we want to subtract f of x from that result. So first I'm going to get a copy. We're going to say now minus f of x is going to be minus 5x squared. Okay. So then we can go ahead and simplify this guy. This cancels this. Notice that all of our remaining terms still have an h, so that's a good omen. All right, that means we're on the right track. So then we're left with 10xh plus 5h squared. Okay. So then the final component, now we're going to say that answer divided by h. We're going to say f of x plus h minus f of x all over h is going to be that 10xh plus 5h squared all over h, right? So then just like before, we can factor out an h from the terms on top. That's the whole point, is that we want to be able to factor out that h. Okay. So then we're going to have 10x plus 5h over h. Now these h's are going to cancel. Oh, okay. So then, all right, so once the h is canceled, we have our 10x plus 5h. And then the final part, now we want to take the limit as h tends to 0 of our difference quotient. So then that's just going to be the limit as h tends to 0 of this 10x plus 5h. So then what's going to happen is essentially this guy goes to 0, okay? And we're left with 10x. Then they wanted us to find f prime of 4. 10 times 4 is 40. And that matches what we got. Okay. Hopefully that's okay. All right. So we did the shortcut, which took us like 2 seconds, and we saw a demo of the difference quotient. They locked me out. Well, that's why we did it before. Okay, that's fine. Let's just get rid of this. Allow. Okay. We were working. Yeah, I mean, we can. It just kind of keeps going. All right, it's a little tough to do a review with this because it's just so many sections, but we still have like another. I'm going to go for like another 30 minutes. Okay, so first for this example, we're asked to graph the reciprocal function. Okay, 4 over x. Let's see, it's either b or d. So for instance, when x is -1, the corresponding y is what? -4, right? So it can't be d, it should be b, right? Okay, we're gonna check that. Let me zoom out, get a better image. Okay. Choose the correct graph of the tangent lines. Draw lines tangent to the graph where x is 0 and x is 1. Okay, I think only one of these graphs matches our original graph, right? So it should be B, because that's the only one where the original graph matches ours. So we're just gonna go with B. Okay. So then f prime of x. Okay. I mean, I guess so. You know how to find this derivative. I guess we can do another demo on the difference quotient. So we have f of x equals 4 over x. So let's hop over here and take some notes. And let's do another demo on the limit definition of the difference quotient. So equals 4 over x, right? Again, you can use a shortcut here. It's totally okay. If you're comfortable with the shortcut, I'm not going to take that away from you, right? And so we're going to do, this will be our last demo on the limit definition. So the limit as h tends to 0 of f of x plus h minus f of x all over h, right? That's what we're going to be working. And I just do it by parts, right? So first, I like to work on f of x plus h. Okay. That's going to be x plus h under 4. Okay. Then the next part, let's go ahead and do f of x plus h minus f of x. So that's going to be this x plus h under 4 minus 4 over x. Okay. Now we could simplify this to get a common denominator. We're going to have to multiply each term by some form of 1. That first term, we're going to multiply by 1 in the form of x over x. The second term, we're going to multiply by 1 in the form of x plus h over x plus h. All right. So in either case, we're only multiplying by 1. It's not going to change our result. It's just going to change the form into something that we can use. All right. So then if we account for these adjustments, we're going to get 4x. Let's see. Let's distribute that -4. So it's going to be 4x minus 4x minus 4h. Okay. And this is x times x plus h. Okay. These guys cancel. Okay. And we are left with x times x plus h under a -4h. Okay. So then the next part, we want to take that result and divide by h. All right. So the next part is f of x plus h minus f of x divided by h. So if we divide that guy by h, what we're gonna, if we kind of simplify, what we'll get is hx x plus h under a -4h, right? So now in this form, because it's all multiplication and division, now we can cancel this h with this guy. Hey Siri, stop the timer. Okay. And we are left with, yeah, it looks good. On bottom, we're going to have x times x plus h. And on top, we're going to have this -4. And then the final part is to incorporate the limit, which is going to be the limit as h tends to 0. On bottom, we got this x times x plus h. On top, we have this -4. Now, if we let h go to 0, then what's going to happen is this guy here is going to go to 0. Okay. And that's going to leave us with x squared under a -4, right? And so if you started with a shortcut, you would have gotten to this immediately or quickly. All right. So we saw the limit definition, and I feel like you guys are proficient on some level in using our shortcuts, right? Hopefully by this point you should be. Like you should have a level of appreciation of those shortcuts, right? Okay, so then F prime. Turn this off. We got a -4 divided by, try that again. -4 divided by x squared. Okay, let's go with that. Okay. So now that we have the derivative, f prime is 0. So when we let x be 0, we got no solution. Because when you plug in 0, you get a number over 0, so that's undefined. And then when x is 1, f prime of 1 is going to be -4. Okay. Okay, I think these are the limit definitions. So, all right, we're going to kind of let that be. Let's take, hey Siri, set a timer for 10 minutes.
10 minutes, starting now.
Let's take some time and work on the next section. Leibniz notation and the power and sum difference rules. Okay, so the rest are like shortcuts, right? Shortcuts that we've been doing, and we're introducing the dy by dx. The Leibniz is the dy by dx, right? That's how that is. That's augmented review. That's 1.2. We want like 1.5. I'm just going until I get to 1.5. Okay. Find the derivative, right? Dy by dx. The derivative of a constant is 0. So that one is just going to be 0. Okay. So we have the square root of x. When we go to take the derivative, we can use the power rule so that 1/2 comes down. We're going to have 5 times x to the power of a -1/2. Let's see. Let me see if I can leave it as a -1/2. We don't usually leave it like that, but I think they might accept it. So I'm just going to submit it and see if it accepts it. Okay. And again, if anything isn't clear, just stop me and get my attention and we can talk about it. Okay. Okay, right? So when we take the derivative here, the first term, we have that square root, that we have the 7th root of x. Remember, that's the same as x to the power of 1/7. So what that means is that when we go to take the derivative, it's fine. I think we'll make it. Oh, I need to watch my battery. Hopefully I can get it to last for another 30 minutes. So when we go to take the square root, the 1/7 comes down. Nope. Let's try that again. 1/7. And then we're going to have x to the power of a negative. So 1/7 minus 1. 7 minus 1 is what? 6. So -6/7. Okay. So that's the derivative of the first term. The second term is -7 times x to the -1. The -1 comes down, becomes a positive. 7x to the -2. Oops. To the power of -2. Okay. So I'm just leaving these with the negative exponents. I'm not rewriting them as like fractions or radicals. I'm just kind of leaving them. Okay. All right. Let's do a couple more. F prime, right? So we're dividing by 3. You can just put that out in front as a third and just let it kind of linger out in front. I'm going to take some notes here a little bit. I'm not going to write. I'm just going to take the notes in this box, in the text box. So that dividing by 3, I'm just going to bring it in front as 1/3. So I'm going to say 1/3. Okay, I'm going to say times. Okay. Now, when we take the derivative, that we can use the power rule, right? So that 7/8 is going to come down. So we're going to say times 7/8. And then we're going to have x to the power of, if you subtract 1, 7/8 minus 8/8 is a negative 1/7. So to the power of a negative 1/7. Okay. 8 times 3 is what, 24? So then it's 7/24. Okay, I'm just going to go with this. Let's see, what did we do wrong? 1/3. We had 7/8. Let me think about it. That comes down, you subtract 1. 8 times 3 is 24. We're going to click on the view an example. Yeah, that's exactly what we did. They should get 5 over what, 6 times 3 is what, 18? And then that's going to be to the power of 2/3. Over 18. Did I not? Oh, I see. I see what I did wrong. I did the denominator right here. That's supposed to be an 8 and not a 7. Okay. Okay, so whatever we did, we got the concept, we just put the wrong base or whatever. Denominator. Okay. Let's try another one. Okay, so again, we are past the 7:15. I guess I need to plug in my device before it dies. Hang on. Okay, so we are past 7:15. If you need to go, I'm not gonna hold it against you if you leave, but I'm just gonna keep streaming until about 7:45. It's like another 20 minutes or so, maybe 15 minutes. Okay. 25 minutes, right? Okay. So given this f of x, find f prime of 3, right? So the derivative is going to be 1/2 x to the negative 1/2. So then we can take some notes here. 1/2. 1/2, our x in this case is going to be what, 3 to the power of a negative 1/2. So it's 1/2 times the square root of 3. Okay, let's write that out. So this is 1/2 times the square root of 3, right? The negative 1/2 moves into the denominator. The power of 1/2 is the same as square root, right? And so that's the exact result. I just need to get rid of those notes. Let me see if I hit this x over here. Okay. Let's go with that. Let's go to the next question. So given this y, we're asked to find dy by dx when x is -2, right? So in other words, take the derivative and evaluate it when x is -2. So this is the same as x to the -10, right? So then the -10 is going to come down. We're going to have our x, which is -2 in this case. If it was -10 and we subtract 1, that's going to be to the power of a -11. Okay. I think I'm gonna just put it in my calculator for the final result. So right here. Reload and refresh. Okay. So I'm just going to do my negative 10 times a negative 2 to the power of a negative 11. Let's see what happens. It says simplify your answer. Can I hit a fraction? Okay, 5 over 1024. So we get 5 over 1024. Let me get rid of this. Okay. 5 over 1024. Okay. Okay. All right, let's keep going. Let me see. Find the equation of a tangent line to the graph of this at these 3 points, right? So we have 3 different x values. So first, let's find the derivative. Maybe we should take some notes. So if I zoom in. Okay. Okay. Copy and delete. Right there. Okay. Hey Siri. Thank you. Okay. Equation of the tangent line, right? So if we want the equation of the tangent line for the line, we're given a point. So the other piece of information that we need is the slope. The slope of the tangent line is the derivative. So basically, we want to find the derivative at these 3 different x values. That'll give us the slope. And then we use the point and we plug it into the y equals mx plus b. Okay. That's the game plan. Okay. So if our f of x is 1 over x squared, then that means that our f prime, let me see, if that's x to the negative 2, you're going to have negative 2x to the negative 3. Okay, I'm going to work with that. Okay. So then for part A, when x is 1, or I'll say at x equals 1, at x equals 1, let me see, f prime of 1 is going to be negative 2. Okay, so that's our slope. So we got a slope of negative 2 passing, and the point is going to be and we got this order pair 1, 1. Okay. So then if we want to find the equation of the line, I like to use y equals mx plus b. Okay. We could use point slope. This is just easier for me. xy, so let me say our y is 1, our slope is negative 2, our x is 1. Only thing we don't know is b. Add 2 to both sides, b equals 3. Okay. So then the equation of our tangent line should be negative 2x plus 3. Okay, that's for part A. And we essentially need to do that for the other parts as well. Okay, so for part B, we have the order pair 3, 1 over 9. Okay. And our f prime is negative 2x to the negative 3. Okay. So, okay. So then f prime of what, 3? See, negative 2 times 3 to the negative 3. 9 times 3, that's 1 over 27. So it looks like it's negative 2 over 27. Okay. Again, this is our slope. And we're given the point 3 comma negative 1 by 9. Okay. So then if we use y equals mx plus b, let me see. So we got our 2 over 27 as a negative.
Professor,
Yes.
is that a 3 comma negative 1 over 9?
Yes.
Okay.
We got our slope. Our x is what? 3. We're solving for b, and our corresponding y is a negative 1 over 9. Okay. So then we'll get b equals, let me see. This 3 turns this into what, a 9? So add 2 over 9 to both sides. It looks like we finished with a 1 over 9. Okay. So then and let's highlight it. So then our equation of our line is going to be a negative 2 over 27 x plus 1 over 9. Okay. And we're going to go with this guy. Okay. I would like to submit these before too long, but we got one more. Let's knock it out. The last one is negative 2 comma 1 over 4. Negative 2 comma 1 over 4. Let's see. And let me get a copy of this. Okay. So when we go to find the slope, basically we're evaluating f prime of negative 2. Let me make sure I got that right. Okay. Let's see. So then that's going to be negative 2 to the power of negative 3. Let me see. That's going to be what? Negative 8. So negative 2 divided by negative 8 is going to be a positive 1 over 4. Okay. Again, this is our slope of our tangent line. So then, and the ordered pair that we're given is this negative 2 comma 1 by 4. So we were given this guy. Okay. So then if we're going to use y equals mx plus b, our slope is the 1 by 4. Our x is a negative 2. We're solving for b, and our y is a 1 by 4. So then our b is going to be equal to, let me see, that's a negative 2 by 4. So we add 2 by 4 to both sides. We get 3 by 4. So the equation of our line is going to be 1 by 4x plus 3 by 4. Okay, I didn't check these. I'm just going to check them by plugging them into Pearson. We have just under 15 minutes remaining. All right, let me see. Hop over to Pearson. Let's zoom out some. Oh. So the equation of the tangent line for part A. We got a negative 2, so y equals a negative 2x plus 3. Okay, we're going to check that. For part B, negative 2 over 27x, negative 2 over 27x plus 1 over 9. Negative 2 over 27x plus 1 over 9. All right, let's see what we do around there. 3 and 1 over 9. Oh, okay, we gotta remove that negative and rework it. Yeah, I introduced a negative. Okay. So let's redo part B. I'll do the corrections in like purple. We accidentally introduced a negative there. Okay, so I think our f prime is good. F prime of 3. I feel like our slope is good. Again, this is supposed to be a positive 1 over 9. Okay. Mx, and this is supposed to be a positive here. So if we add 2 over 9 to both sides, 2 over 9 plus 1 over 9, that's supposed to be a 3 over 9. Right there, that's supposed to be a 3. It's supposed to be a 3 over 9. Okay. So that makes this a 3 over 9. Okay. So it wasn't too bad. Let's make sure. Oh, 3 over 9 becomes a third. So we're going to write that as a third. So right here. So that becomes 1 over 3. Okay. And then for part C, we got 1 over 1/4 x plus 3/4. All right, we get y equals 1/4 x plus 3/4. Okay. All right. Okay, it is definitely past my bedtime, man. I don't know. Man, everything is like so topsy-turvy. You know, I don't know if it's I'm getting older. Let me kind of go on to the next section. So that's 1.5. Let's do some questions from 1.6. Ho, ho, ho. Okay, product rule and quotient rules, right? So now we're into the shortcuts, right? And and it is charging. Ooh, that was a weird sound. That sounds sent a shockwave through me for some reason. My device is totally about to conk out. Hopefully, well, we said 7:45. I'm just going to go for a few more minutes. Basically, find the derivative, right? So we got x to the negative 11. So the power comes down, negative 11x to the power of a negative 12. I'm just going to go with it like that. Okay. All right. So this is 3x to the power of 1/5. So then when we go to take the derivative, that 1/5 comes down. We're still going to have this 3x, but now it's going to be to the power of 1/5 minus 5/5 is a negative 4/5. So negative 4 over 5. Okay. And then the derivative of the inside is going to be a 3. So we're going to say times 3. So I'm going to put that 3 right here, right there. I want that to be a 3. Because we're basically multiplying by 3. So basically that was a chain rule, right? We did the derivative of the outside function times the derivative of the inside function. That's what we did there. Use a product rule. I just don't like the way this one is worded. I mean, I get it. Well, this is fine. So if we're doing the product rule, it's going to be what the first times the derivative of the second plus the second times the derivative of the first, all right? So I think it's B first, okay, no, let's go like this, right? With E, the derivative of the second is going to be what? 7x to the 6. So this needs to be 7x to the power of 6. Okay. First times the derivative of the second plus the second. The derivative of the first is 6x to the power of 5. Okay. All right. Simplify your answer. Okay, so if we multiply these guys, we're going to get x to the power of 13. Okay. Now, if we take that derivative, we're going to get 13x to the power of 12. 13x to the power of 12. Okay. Oh, that was it for that one? Oh, okay. All right, if we're using the product rule, so the first times the derivative of the second plus the second times the derivative of the first, okay, right here. Right. So the derivative of the second is going to be what? 3z squared minus 4. So that's the first times the derivative of the second plus the second times the derivative of the first is just going to be negative 2z. Okay, I'm going to submit that. Okay, so if we expand this guy, there's a lot going on there. Okay. So we're going to have 4z cubed minus z to the power of 5 minus 16z, okay, plus 4z to the power of 3, 4z to the power of 3, okay, plus 20 minus 5z squared. Okay, looks like we don't have any like terms, so we might be able to just submit it as is. I'm just going to go with that. Let's see. I don't see any like terms. Let me check again. Because I see my constant 1, 2, 3. Do they want it in descending power order? Does that matter? It shouldn't matter. Let me see. 4z cubed minus z to the power of 5. 16, yeah, plus 4z cubed, okay. 20 minus 5z squared. They can't possibly want this in descending power order. Is that what it is?
Professor, I see 2 for z to the cube.
Oh, okay. Let's see. Right there. And yeah, you're right. So that's a 8z cubed, right? Okay. Thank you for that. Right here.
You're welcome.
8z cubed. Oh, come on. Okay, let me see if I think if I zoom out. Okay. So this there, like that. Okay. Okay, that was good looking. We got a couple more minutes. Let's see. So using either approach, find the derivative, right? So we could just take the derivative of that above result instead of doing the product rule, because that one looks like the product rule might get extensive. So we're just going to take the derivative of the result that we just found, if we can get this to behave. Okay, I'm just going to start typing. 24, there it is. 24z squared minus 5z to the 4. Okay. Minus 16. The constant is gone, and then we're going to say minus 10z. Okay. All right, let's try to do one more and then we'll call it a day. Let's do one more. So differentiate. Yeah, I guess we should do the product rule. I'm going to take my notes here. Okay, so the first is going to be this guy, 6x squared. Hopefully this is going to work out. 6x squared plus 5. So that's the first times the derivative of the second. The derivative of the second is going to be 3 plus 1/2 x to the power of a negative 1/2. Okay. So that's the first times the derivative of the second. Now we're going to say plus the second, which is 3x plus the square root of x. So that's the first times the derivative of the second plus the second. Now the derivative of the first is going to be what? 12x. That's it. Okay. I'm tempted to submit this. I'm trying to see if I can like factor anything, or I don't see anything that factors. We could expand that. I'm going to submit this. Okay. All right, that was one more, right? All right. So, you know, it took us a little while to get going, so we compensated by saying like 30 minutes later, and I let people go at 15-minute mark or whatever. Are there any other burning questions? Would you guys like to work on any more? We can kind of do some more. I am a little exhausted, and I tend to make more and more questions. All right. All right. So going once, going twice. Okay. So if there aren't any burning questions, so again, our exam 1 is available right now. Hopefully you guys are making your way through it. You get unlimited attempts. It should be due this upcoming Sunday at 11:59 p.m. going into Monday morning. So then after exam 1, we'll meet for like 2 more weeks. We'll have week 7. So we'll start working on chapter 3, right? I just got to look at the schedule and see what the rhythm is. But we'll do 2 weeks, and again, week 8, you know, that's going to be the week right before spring break. We'll leave for spring break, and then after spring break, we'll come back and continue working chapter 3. All right. So again, we have 2 exams in the final. Exam 1 is basically chapters 1 and 2. So then exam 2 are going to be chapters 3 and 4, and then the final is going to be everything from the beginning to the end. Okay. All right. So with that, if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy your weekend, guys. Take care. Peace.
Bye, Professor.